Alrighty, so we're looking at this situation. We've just added 0.2 moles of OH. It's still 1 liter. So what we have in the solution is 0.6 moles of acetic acid. We've added 0.2, but we don't know the H+ concentration. We don't know how many of these protons are actually have been donated to water. So that's what we need to figure out now. It's not a strong acid, so a little bit more complicated. All right, so what we've got is this solution. If it was a strong acid, it'd be nice and easy, 0.6 moles of protons, but 0.6 molar protons. So here we've got acetic acid. This is the equilibrium expression for it. So we can write that Ka. Right, we have that. And just as a reminder, we are using here H+ instead of H3O+. Just is a little bit easier to use, a little bit simpler. So this is our, we would ignore the water anyway. So here we have this. The Ka, it's a weak acid, so we do expect these concentrations to be fairly small. Just how small? Well, you got to look it up. So Ka, we can look it up on a chart. 1.5 times 10 to the -5th. All right. So do you need to memorize that? I don't think so. It's just another number, but if you want to. Okay. So we know this. We know this, and we know that this concentration is going to drop a little bit, right? If this is in solution, right, and we have 0.6 moles of it in 1 liter, then some of this, a little bit of this at least, is going to dissociate. So this concentration won't be quite 0.6 molar, not quite, but it should be close, right? So this is a weak acid. We are going to approximate it to be 0.6 molar. We're going to leave that. We're going to ignore that some of this comes off. And you have to check and make sure that that works. We'll look at that another time. But so it does work for this situation, right? It is okay to say that our concentration of acetic acid is 0.6 molar. It's okay. It is a little bit less than that, but it's okay to say, all right, that's going to be 0.6 molar. So that makes it a bit simpler, right? So if we know that whatever the concentration of H+ is, that's going to be the same as the concentration of acetate, and that should be fair. That is going to be small enough that it's going to be okay. So we know this. We're going to take it as 0.6 molar, and we know this. It's 1.8 times 10 to the -5th. That's X. That's X. So we can rearrange, and this is 0.6 times 1.8 times 10 to the -5th equals X squared. Take the square root, and you get concentration of H+ equals, what is it? 3.3 times 10 to the -3rd. All right, so we have our H+ concentration. That's also the concentration of acetate. So we have our H+ concentration. It's pretty small. And let's go back to the other problem. So after adding 0.2 molar hydroxide, we have 0.6 molar acetic acid. So negative log 3.3 times 10 to the -3rd. And the pH there, 2.5. It's 2.5. I'm going to run out of space, so I'm going to rewrite, but that's 2.5. All right, now let's add more hydroxide. See what happens. So putting in another OH, I'm going to write it, let's see, down here. OH minus, and I'm just going to take that proton, right? Take that proton back off of the acetate. So now what we have is a situation where we still have acetic acid. We've got 0.5 molar acetic acid, but we also have acetate, and we have a sizable concentration of it. We know that it's actually 0.1 molar, right? It's 0.5 molar acetic acid, 0.1 molar acetate. So that is actually going to complicate the concentration of H+. Right? Before these were both fairly small, and they were the same. But now there's a lot more of this. All right, so we that's the situation we have now. So we have this concentration and we have this concentration. We're still trying to figure out H+, so all we need to do is rearrange this. And we know Ka. We still know Ka for this this situation. So we just got to rearrange this a little bit. And I'm just going to get everything away from H+. All right, so we know Ka. Now this is 0.5 divided by 0.1, and that's our H+. And what is that? Yep. Right, so there's your H+ concentration. So we've got, after 0.3, the H+ concentration is 9.0 times 10 to the negative fifth. And if we take the negative log of that, we get about 4. I think 4.0. 4.0. So we can see how the pH is changing. We'll go back and compare this to the first situation in a few minutes. Let's add more OH. So I'll do it down here. Got more OH, right? Taking back the protons from that original acetate. Yeah, it doesn't really matter where I do it. But what we have now, we have 0.4 molar acetic acid, 0.2 molar acetate, and the rest is all water. So let's figure that out. This is changing. This changes. And 3.6 times 10 to the negative fifth. It is going down, right? So that's good. 4.4. More OH. More OH. I'm gonna stay over here. OH. All right. So now we have 0.3 moles of acetate. We have 0.3 moles of acetic acid. That's what we started with up here, right? That was the thing that we added added there. Again, we're still taking this as 1 liter, right? We're not changing the volume, so the concentrations are the same. So this is 0.3 molar acetate, 0.3 molar acetic acid, and some water. Can you see something? 0.3, 0.3, that will cancel. Guys, that is the Ka of acetic acid. We have an equal amount of acetic acid and acetate in this solution, right? Same concentration in the solution, and now the pH is going to be the same as the pKa, right? Because this is the H+. This is the concentration of H+ in solution. 4.7, 4.74, something like that. Let's keep going. Let's keep going. See if we add more hydroxide over here. Now that's it's going to take that proton off, so we're going to be left with even more acetate and even less acetic acid. Changes. Alrighty. What was this? 2. This is 0.4. 0.2. And what's this coming to be? 9 times 10 to the 6. Alright, so that's the concentration of H+ for 0.2 molar acetic acid and 0.4 molar acetate. 5.1, something like that. Again, we're going to do this a couple more times. So we got OH, that right there. 0.1 molar acetic acid, 0.5 molar acetate. Going down. It should be going down because we have less acetic acid there. We are neutralizing it. So after 0.7, that's 5.4. So let's add one more. Now we have 0.6 molar acetate. We don't have any acetic acid anymore. Right? This is gone. So I gotta look. What did I do? I gotta look. Now we have the Kb for acetate. That's what we gotta look at now. So the Kb for acetate. Maybe you can take this. Gone. Alright, so 0.6 molar acetate, and I just want to collect my thought.